Section 9.1. Solve by completing the square. There are many ways to solve quadratic equations. When you hear the word quadratic, you should be thinking of x squared or y squared. Now, the four ways we're going to learn to solve quadratics or review to solve quadratics are these. The first one was to factor and use the zero factor theorem. The zero factor theorem stated if a times b equaled 0, then a equaled 0 or b would equal 0. Number 2, we have the square root property, which we'll talk about as well. Number 3, completing the square. And number 4, quadratic formula. So these are the four different ways to solve quadratic equations. Some methods work all the time, some methods work some of the time. So try and figure out which is the best method. So let's talk about the square root property. The square root property stated that if you had some quantity squared equaling a constant, we'll put an x in the parentheses, but it could be a binomial in there as well. So if x squared equaled c, a constant, then we could take the square root of both sides. Well, when we take the square root of both sides on the left and on the right, you'll see that on the left-hand side, the square and the square root cancel each other out. So we get x equaling plus or minus the square root of c. So the square root property is nice, but it only works in that specific circumstance, when you have one quantity squared equaling a constant. These are all solving quadratics, so you need to pick which is the best method. Number 1, x squared equaling 25. You actually could factor or use the square root property. But I'm going to use the square root property because we do have a quantity squared equaling a constant. So I will take the square root of the left plus or minus the square root of the right because we have two answers with square roots. On the left hand side, the square and the square root just cancel. And on the right hand side, the square root of 25 is 5. So the square root property definitely worked. But what if we tried to factor instead? So you'd subtract over the 25 and make it equal to 0. Is it factorable? Yes, it factors into x plus 5 times x minus 5 equaling 0. Setting each of those factors equal to 0, you'll see that we end up getting the same two answers. We get x equaling plus or minus 5. Number 2, y squared equals 5 over 9. It looks like it's a square root property because it has a quantity squared equaling a constant. So all we need to do is take the square root of the left and it equals plus or minus the square root of the right. On the left hand side, the square and the square root cancel each other out, so I'm left with y. Plus or minus, we can take the square roots of pieces because there is no glue with plus signs or minus signs. So we can say the square root of 5 is just the square root of 5, and the square root of 9 is 3. So I do have two answers. The first answer is the square root of 5 over 3, and the second answer is negative square root of 5 over 3. With a quadratic, when you have a square, you should come up with two answers. Number 3, x squared plus 8 equals 0. If we try and factor it, we cannot. So therefore, factoring technique is out. Step 2 said, why don't we try the square root property? If we subtract over the 8, we get x squared equaling negative 8. We do have a square equaling a constant. So we can take the square root of the left and plus or minus the square root of the right. On the left-hand side, the square and the square root just cancel each other out. Plus or minus, well, we learned that when there's a negative under square root, there should be an I that comes out because I is representing the square root of negative 1. 8 is 4 times 2, and 4 is 2 times 2. So 2 is also going to come out, and what's left underneath is a 2. So we end up with x equaling plus or minus 2i square root of 2. Really, the I should go at the end of the radical, but don't put it underneath. I will accept it in front or at the end of the radical, just don't put it under the radical because it is a radical. Number 4, 9x squared minus 20 equaling 0. Well, it is a binomial. When we do try and factor, we cannot factor it because it's not a difference of squares. So let's go ahead and try the square root property. Let's add over the 20, so 9x squared equals 20. We'll then divide both sides by 9 to get the x squared by itself. So x squared will equal 20 over 9. Now that we see we have a square equaling a constant, all we need to do is take the square root of the left, and don't forget plus or minus the square root of the right. On the left-hand side, the square and the square root just cancel each other out. And on the right-hand side, let's break that up into the square root of 20 over the square root of 9. Well, we know what the square root of 9 is. The square root of 9 is just 3, so we're left with a 3 in the denominator. What can we do with the 20? Well, 20 breaks up into 4 times 5, and 4 is 2 times 2. So a 2 is going to come out, and a 5 is going to be left underneath. So my final answer is x equaling plus or minus 2 square root of 5 all over 3. Number 5. Parentheses 3y plus 7 quantity squared equaling 1. We could do the old-fashioned way, because you know what to do with 3y plus 7. You would write it twice and FOIL it out. However, if you notice, this is the square root property. We have a quantity squared equaling a constant. So we could go ahead and just take the square root of the left equaling plus or minus the square root of the right. On the left-hand side, the square and the square root cancel each other out, so we're left with 3y plus 7 equaling plus or minus, what's the square root of 1 is just 1. Now we're not done. We haven't solved for y yet. So we need to take 3y plus 7 and equal it to a positive 1, or 3y plus 7 would have to equal the negative 1. And now we'll solve each of those linear equations. I'll subtract over the 7, so 3y equals negative 6, divide by 3, so y is going to equal negative 2. On the other side, I'll subtract the 7, so 3y is going to equal negative 8, divide by 3 on both sides, so y is going to equal a negative 8/3. Both answers should check, so if you have time, I would check your answers. Number 6. 6x minus 7 quantity squared equaling negative 75. Again, the old technique would be to multiply out 6x minus 7 times 6x minus 7, bring over the negative 75, and all that. You could do that method. However, it is a square root property. We have a quantity squared equaling a constant. So what can we do? We can take the square root of the left, the square root of 6x minus 7 quantity squared, equaling plus or minus the square root of negative 75. On the left-hand side, the square and the square root cancel each other out, so I get 6x minus 7 equaling plus or minus. Well, we see the negative under the square root, so we know there's going to be an I out there. What about 75? Well, 75 would be 25 times 3, and 25 is 5 times 5. So 5 is also going to come out, and what's left underneath is the 3. We have not solved yet. We still need to know what x equals. So we could separate it into two equations. 6x minus 7 equals 5i squared to 3, or 6x minus 7 has to equal negative 5i squared to 3. If you want to keep the answers all together, go right ahead, but I'm going to separate them for now. So I'll add over the 7. Those are not like terms, so I'll need to leave that as 7 plus 5i squared to 3. To get x by itself, I'll divide by 6. Because these are complex numbers with an I, you do need to separate the real part from the imaginary part. So my final answer would be x equaling 7/6 plus 5i squared to 3 over 6. Make sure you separate it into the real part and the imaginary part. For the other problem, we need to also add over the 7. Again, those are not like terms, so I get 6x equaling 7 minus 5i squared to 3. I'll then need to divide both sides by 6, and we'll separate those into two answers, the real part and the imaginary part. So 7 over 6 minus 5i squared to 3 over 6. If you want to put the I in front, I'll accept that for now. If you want to put the I at the end of the radical, that would be better. You could keep them together as one answer, and that would look like x equaling 7 over 6 plus or minus 5 squared to 3i over 6. So you could certainly keep those answers together. Alright, so now let's learn how to solve by completing the square. Well, completing the square, you kind of want to set it up differently than if you were trying to solve using the factor theorem. You're going to want the ax squared plus bx on one side, and you're going to want the c on the other side of the equal sign. Now, if the number in front of x squared, step 2, if a is 1, go on to step 3. But if a is not 1, what you have to do is divide every term by a so that the leading coefficient is now 1. Then you're going to do some steps. The next step, step 3, is to take half of the b term, so divide it by 2, half of the b term, square that number, so whatever you got when you divided by 2, you're now going to square that number, and then add that number to both sides. That's going to keep your equation balanced. Now, why do we do those crazy steps? Because the left-hand side should be able to be written as a perfect square by factoring. So write the left side as a perfect square, and then factor. The completing the square actually changes your problem into the square root property. So at this point you can solve by using the square root property, and those would be your answers. So number 1, it does say solve by completing the square. X squared minus 2x equals 8. Let's follow the steps. The first step is to make x squared and x be on the same side and the constant be on the other. It already is. The second step is to make sure that the number in front of x squared, which is the leading coefficient, is 1. And it is. Now we need to take half of the b term, square that number, and then add it to both sides. So what is b? Well, b is negative 2. So we're going to divide negative 2 by 2, and we're going to end up with negative 1. Then what do we do with the negative 1? We then square it, and that's going to give me a positive 1, and we're going to add 1 to both sides. So that's going to look like x squared minus 2x plus 1, and equaling 8 plus 1. So let's go over that again. We took half of the b term, so divide b by 2. Whatever that number is, then you square it, and that's the number you add to both sides. The reason why we do these crazy steps is because the left-hand side now is a perfect square, so we can factor it. It's just your C method, so factors of 1 that add up to negative 2 are negative 1 and negative 1, so that factors into x minus 1 times x minus 1. And we know we can rewrite that as x minus 1 quantity squared. And 8 plus 1 is 9. So now we can take the square root of both sides because we're in the square root property. So the square root of the left and the square root of the right, not forgetting plus or minus. So x minus 1 equals plus or minus, and the square root of 9 is just 3. So we'll need that to break this up into x minus 1 equaling positive 3, or x minus 1 has to equal negative 3. Add over the 1, we get x equaling 4. Add over the 1, we get x equaling negative 2. Both of those answers should work. Number 2, y squared plus 10y plus 22 equals 0. Since the direction said to solve by completing the square, the first thing we need to do is subtract the 22 over to the other side. So I'll end up with y squared plus 10y equaling negative 22. The second step is to make sure the number in front of y squared is a 1, and it is. Third step is to find out what b is, so let's go through that step. b is 10. Then we're going to take half of 10, so 10 divided by 2 is 5. And then what do we do with the 5? We square it, and we're going to get 25, and we'll add 25 to both sides. So we'll add 25 to the left, and we'll add 25 to the right. Again, the reason why we do that is because the left-hand side should now be factorable. Factors of 25 that add up to 10 are 5 and 5, so y plus 5 times y plus 5. And y plus 5 times y plus 5 is just y plus 5 quantity squared. On the right-hand side, negative 22 plus 25 is 3. So then we could take the square root of the left and the square root of the right, not forgetting plus or minus. So on the left-hand side, the square and the square root just cancel each other out, and we get plus or minus the square root of 3 on the right-hand side. So we'll subtract the 5 to bring it over to the other side. They're not like terms, so they cannot be put together. We'll write that as y equaling negative 5 plus or minus the square root of 3. You can keep the answers all together, or you may separate them if you'd like. Number 3, y squared minus 5y minus 2 equals 0. So we're now going to have to probably deal with some fractions, so I wanted to do some with you. This does say to solve by completing the square. However, if I give it to you on the test and I just say solve, you could do quadratic formula, you could do completing the square, either one would work. Now, factoring does not. There are no factors of negative 2 that add up to negative 5. So factoring is out, and it's not the square root property. Well, let's go ahead and do completing the square. So for number 3, y squared minus 5y minus 2 equaling 0, the first thing we need to do is add over the 2. So taking the 2 over to the other side. Now we need to do the steps of taking half of the b term, square it, and add it to both sides. So b is negative 5. Half of negative 5 is negative 5 over 2. Then we need to square that number. So negative 5 squared is 25 and 2 squared is 4. So we're going to need to add 25 over 4 to both sides. Now, how do we factor the left-hand side then? Well, what's great is you just look at what was in parentheses before you squared it, and those should be the numbers you use. So in the parentheses was negative 5 halves before I squared it. So this should be able to be factored into y minus 5 halves times y minus 5 halves. Negative 5 halves times negative 5 halves is still 25 over 4. And if you test the outer and the inner, negative 5 halves y minus 5 halves y is negative 10 halves, which gives you that negative 5y. So it does work out. So just remember that whatever was in parentheses is what's going to be the numbers you use when you try and factor. On the right hand side, we do need to find a common denominator to put those together. Well, common denominator would be 4, so that would be an 8, and 25 over 4 will stay as is. So we said y minus 5 halves times y minus 5 halves could be rewritten as y minus 5 halves quantity squared. On the right hand side, 8 plus 25 is 33, so you get 33 over 4. Now we're in the square root property, so we'll take the square root of both sides, not forgetting plus or minus. On the left hand side, the square and the square root cancel each other out. On the right hand side, we'll do the square root of 33. Nothing can come out of that, but the square root of 4 is 2. Last step is to get y by itself, so I'll need to add over the 5 halves. So y equals 5 halves plus or minus the square root of 33 over 2. There are no like terms, so you're done. Number 4. 3x squared minus 9x minus 12 equals 0. If we're going to complete the square, the first thing to do is take the negative 12 over to the other side. So I get 3x squared minus 9x equals a positive 12. The next step is to look at the number in front of x squared. It's not a 1 in this example, so I need to divide everything by that leading coefficient so that the leading coefficient will then become 1. So we end up with x squared minus 3x equaling 12 divided by 3 is 4. Now we'll need to take half of the b term, square it, and add it to both sides. So the b is negative 3. Half of negative 3 is negative 3 over 2. When we square that, we get 9 over 4. So we're going to add 9/4 to both sides. So on the left-hand side, what was in parentheses before we squared it was negative 3 halves. So this should factor into x minus 3 halves times x minus 3 halves. On the right hand side, we'll definitely need to find a common denominator. Between a 1 and a 4 is a 4, so 4 times 4 is 16, and that can stay 9 over 4. On the left hand side, we rewrite x minus 3 halves times x minus 3 halves as x minus 3 halves quantity squared. And 16/4 plus 9/4 is 25/4. Now we can take the square root of both sides, again not forgetting plus or minus on the right hand side. So the left hand side cancels out, and on the right hand, plus or minus, well, the square root of 25 is 5, and the square root of 4 is 2. So this actually tells me this was factorable from the beginning, but the directions did say to solve by completing the square. So I'll add 3 halves over to the other side, and I'll end up with x equaling 3 halves plus or minus 5 halves. So we can go farther. 3 halves plus 5 halves is 8 halves, which turns out to be a 4. And 3 halves minus 5 halves is negative 2 over 2, which is negative 1. So my answers are x equaling 4 and negative 1. So number 5 has 5x squared plus 12x minus 1 equaling 0. First step would be to add over the 1 to the other side. So I get 5x squared plus 12x equals 1. Now, the number in front of x squared is not 1, so I'll need to divide everything by 5. When I do so, I get x squared plus 12x over 5 equaling 1 over 5. Well, now let's do the steps of finding what do we need to add to both sides. So b is 12 over 5. We need to take half of that. So that just means dividing by 2. There's already a 5 down there, so 2 times 5 is 10. Then we're going to reduce 12 over 10. 12 over 10 reduces to 6 over 5, and then we need to square that. So we're going to need to add to both sides 36 over 25. So again, we take half of the b term, square that number, and add it to both sides. So what that's going to look like is x squared plus 12x over 5. We're going to add 36 over 25 to the left-hand side. So we'll need to take 1/5 and add 36 over 25 to the right-hand side. One last step I'll do for you is on the left-hand side. This is going to factor into x plus, what was in parentheses before we squared it was 6/5. So x plus 6/5 quantity squared. Find your common denominator on the right-hand side and continue. So our final answer for that one would be x equaling negative 6/5 plus or minus square root of 41 all over 5 as well.